Okay, we're moving on to a new topic here, and that's independent events and the multiplication rule that we'll be doing this week. So we've got three lessons on that, and we'll see how this goes. So if we start off here, two events are independent. So the first box on your notes is the word independent. If the occurrence of one does not affect the probability of the other. Technical difficulty here. There you go. So they're independent if the occurrence of one does not affect the probability of the other. Again, we'll get into more of what that means in a little bit, but that's the idea of independent. And then your second box on your notes is the word dependent, and it is simply if two events are not independent. Okay, so independent events, if the occurrence of one does not affect the probability of the other. So what exactly does that mean? If you flip a coin twice, okay, the result on the first flip is independent of the result on the second flip. Okay, which means essentially if I flip a heads on the first flip, I can still flip either a heads or a tail. I still have a 50-50 shot on the second flip. Okay, so consider the situation where a coin is flipped twice. Let A be the event of getting heads on the first flip. What's the probability of A? So we should understand we're only on a first flip. Okay, there's one head on the coin. There's two sides to the coin. So the probability of A is 1/2, or if you want to put it as a decimal or as a percent, again, you choose how you want to write it. Okay, let B be the event of getting a head on the second flip. Now realize this has nothing to do with the first flip. Okay, so on the second flip, if our only thing that happens is the second flip, probability of B. So a head, there is one head, and there are two sides to the coin. So the probability of B is 1/2 as well. Draw a tree diagram that illustrates the sample space of flipping a coin twice. Okay, so this idea is that we have two coins. The first coin is flipped. We either get a heads or a tails. So that represents the first coin. If you got a heads on the first one, you flip the second one and you either get a heads or a tails. If you got a tails on the first one, you flip the second one and either get a heads or a tails, which means that our sample space that comes out of this is either we're going to get a head and then a head, we're going to get a head and then a tail, we'll get a tail and then a head, or a tail and a tail. Okay, those are our four things that are in the sample space. Each of these have the same probability. Okay, but this is our tree diagram here. Given that the outcomes in the sample space for flipping a coin twice are equally likely, determine the probability of getting a head on the first flip and a head on the second flip. Okay, in other words, find the probability of getting HH, which is the event of A intersect B. Okay, so the probability of getting HH, if I look at this and they're equally likely, is there is, out of this set, there is one HH and there are four things total, is 1/4. Okay, so parts A, B, and D show the multiplication rule for independent events. So what is this rule? Okay, I'm going to highlight that idea because that's one of our big ideas. Okay, if A and B are independent events, then the probability of A intersect B is equal to the probability of A times the probability of B. Okay, so this is my multiplication rule right here. Okay, so we just said that the probability of HH is the probability of A intersect B. Okay, so what this is saying right here is that the probability of A intersect B, which we said was 1/4, is equal to the probability of A, we found the probability of A to be 1/2, times the probability of B, which is 1/2. Okay, notice that that is equal. Okay, so if for any events A and B, A intersect B is equal to the probability of A times probability of B, then A and B are independent events. So what we just showed here is since these things all worked out, then these are independent events. There are two ways, and so we decided independent since we did a check there. Okay, so there are two ways we will use this. We will use this to say if I know, so if the first thing that I know is that I have independent events, then I'm going to be able to find a probability of A intersect B based on only knowing the probability of A and the probability of B. Or if I know that the probability of A intersect B is equal to the probability of A times the probability of B, then I'm going to be able to say that those events are independent. Okay, so there's two ways that we're going to go through this formula here. Okay, I'm going to go through, I think it's three problems here, and then let you guys work on the rest of them, and the answers are on Google Classroom. Okay, so number 2, right at the bottom of the first page, Sonia has a container with 5 blue marbles. So we have those 5 blue marbles. It's got 3 red marbles and 2 green marbles. Okay, Sophia draws a marble out of the box and records its color. She returns the marble to the container. So we already know from previous instances that's a big deal. Before drawing a second marble and recording its color, let A be the event that Sonia chooses a red marble on the first draw. So A is that she chooses a red marble on the first draw, and then B is the event that she chooses a blue marble on the second draw. Okay. Why are A and B independent events? So just a simple explanation. These are independent because she returns the marble, which means that the probability does not change. So if you imagine this, if she didn't return the marble, when you draw the first one, you now only have 9 marbles left for the second one, which means that these would not be independent events, okay? But by returning it in this case, they stay independent. Okay? So since we know that these are independent events, I'm going to use the fact that they're independent to use the multiplication rule. So use the multiplication rule for independent events to find the probability of drawing a red marble in the first draw and a blue marble in the second draw. In other words, find the probability of A intersect B. So we know that the probability of A intersect B is equal to the probability of A times the probability of B. So what I need to do right now is find the probability of A. Okay, so the probability of A, remember A is the event that she chooses a red marble. So there were 3 red marbles on the first draw. Okay, so 3 out of a bag of 10 or a container of 10, okay, times the probability of B. So B is the event that she chooses a blue marble. So there are 5 blue marbles out of a possible of 10. Now remember, that number would have changed to 9 if we didn't return them. So that's why this is independent here. So it's 3 out of 10 and 5 out of 10, which if we multiply those together, we get 15 out of 100, which can be written as 0.15. So you can simplify your fraction if you want to. You can write it as a decimal or you can write it as a percent. This is one where I kind of look at it as a percent because I see that 15 out of 100 and know how to switch that. So your 9, 10, and 11 questions are going to be similar to this one. So look back to this idea in order to figure out how to do 9, 10, and 11. Okay, I'm going to keep going here. Number 3, so if you flip the page, top of the page, we are going to roll a fair die. So all that this means is that it's not a weighted die. It's not a magic die, anything like that, okay? It's got 1, 2, 3, 4, 5, and 6 on the sides. Let A be the event of rolling an even number, okay? So we have A is an even number, okay? This is my set notation, so I'm going to just list all of my even numbers. There's 2, 4, and 6, okay? Let B be the event of rolling a number greater than 3. Okay, so greater than 3, not greater than or equal to, so we have to start at 4, 5, and 6. There's my event B. Okay, and then A intersect B, remember, is anything that is in both of them. So 2 not in B, 4 is there, so we put 4 in here, and 6 and 6. Okay, so this is 4 and 6. Okay, so that's what we have. The probability of A, there are 3 things in A, and there are 6 in the sample space, is 1/2. The probability of B, there are 3 things in B, there's 6 in the sample space, is 1/2. The probability of A intersect B, there's 2 things in the intersection, there's 6 in the sample space, is 1/3. Okay, so use the multiplication rule for independent events to determine whether A and B are independent or dependent. And this is where it gets confusing. I'm not going to beat around the bush or anything. Feel free to go watch some videos on these ideas, but a lot of people are going to be confused when I get to the answer here. Okay, so multiplication rule for independent events to decide whether A and B are independent. So what I do is I do the probability of A times the probability of B. Okay, probability of A times the probability of B, which is going to be 1/2 times 1/2, which is equal to 1/4. Okay, and then I need to look at the probability of A intersect B, which is 1/3. Take that line away. And notice that those are not equal, which means since these are not independent, is that these events are dependent on each other. Okay, it gets confusing. okay? Use the rule is the best thing I can tell you is go back to using the rule every single time. There are more explanations out there, but it gets a little bit complicated. You'll probably understand this idea more when we get a little bit further along in the notes, okay? So use the rule for now and go from there. 4 and 5 are the ones that are like that. Okay, so number 6, and this is the same diagram for 7 and 8, and I know it's a little bit hard to see, so just look at mine. The red, you can see how far that goes, and then the blue, you can see how far that goes to figure out your two events there. So event A and B are represented by rectangular regions in the area probability model. So that means that this is to scale. Okay, it's based on these little boxes that we have here. The sample space is represented by the rectangular region S. Okay, and use the diagram to determine. So what I'm going to do first is just find the areas of each of these. Okay, so A is a 4 by 6 box. Okay, so it's going to have a area of 24. B is a 3 by 8 box, so it's going to have an area of 24, so they happen to have the same area. And then S is a 12 by 8 box, so it's going to have an area of 96. Okay, so I'm going to be using those pieces of information as I go through this. Don't know where that line came from. There we go. Okay, so using that information, the probability of A, okay, is the area of A, which we decided was 24, out of the area of the entire sample space, which is 96. Okay, so 24 out of 96 will simplify to 1/4, and you decide how you want to do that. I'm putting that in my calculator just to be clear. Okay, probability of B is also 24 out of 96, not because of A, but just because they happen to have the same area. Okay, and so that's going to come out to 1/4 as well. Let me just stop writing on this side of my screen. Okay. Sorry, some technical difficulties here again. So the probability of A intersect B, okay, where do they intersect? So you can see that right in here, and that's 6 units, is 6 out of 96, which is going to give you 1/16. Okay, so then use the multiplication rule. So A and B aren't anything that you can look at and you can say, okay, I know about this, it's independent, okay? So we don't know that they're independent or dependent. We're going to use the multiplication rule to figure that out. So we're going to look at the probability of A, okay, times the probability of B, and whether it's equal to the probability of A intersect B or not. Okay, so we're trying to figure out what's the symbol that can go in there. Okay, so the probability of A was 1/4, the probability of B was 1/4. Multiply those together, you get 1/16. This and this are the same, and so therefore we can put an equal sign in here, and that means that these are independent. Okay. So that's where I'm going to leave you guys. I guess I should have looked at the questions. 7 and 8 are the ones that are there. That's what I'm going to leave you guys for today. Try out the questions and please let me know if you need help on any of them and I will make another video. Like I said for this one though, the independent or dependent, just go based on the rule. You're probably going to understand the idea more later as we go through this.